Hello everyone, hello everyone. Tonight I'm gonna tell you how you can turn your existing Angular application into the mobile money maker, and I will guide you through the steps that are necessary to transform your existing Angular app, uh, connect in-app payments to it, and publish it on the App Store and Google Play, and generate revenue with it. So let's dive in. First of all, I wanted to ask the audience, please comment plus in chat if you think that Angular is good for web, but not really suitable for mobile. Okay, guys, spoiler alert, Angular is a very good web framework, but it's really terrible for mobile. Because obviously, Angular doesn't have any native mobile features. It doesn't have any cross-platform support compared to React Native or Flutter. And also in development, it's much slower than React, in my opinion, because it has some boilerplate, right? But what if after years of development of a big and successful project, a client now wants to cost efficiently create new revenue source and literally ship the same features that already exist in a web application to the App Store, but also keep the existing code unchanged. And last year, I had such a success story where we just transformed an existing Angular app, published it to the App Store, and the application has managed to generate. I can't tell the exact numbers, but it managed to generate more than 200,000 euro in just 2 months. And I want to explore the key steps that were involved into the process of creating such an application. And I remember the day when client asked me if we can publish our existing app to the App Store. I had so many questions and doubts in my head. How will it look like? How will it feel like? What technology should we use? And will this even feel like a native app? And will users like it? So I responded, let's start. Let's do it right now. But then I faced real challenges. So first of all, we had an existing UI with header, with footer, with all the content. And you already may know that there is an Ionic framework which perfectly works with Angular, but it also has its own components for mobile applications. But how do we integrate these components? Because we didn't want to clash the frameworks, because we wanted to keep the existing UI. And many of our features relied on the browser API, for example, for downloading files, for opening new tabs and different things, copying stuff. And none of this works on the mobile anymore because there are no tabs on the mobile, as you may know. And also, we used Stripe for payments, but Apple and Google have very strict payment guidelines because they want to collect 30% fees or commission from each purchase users make on your application. And if you try to avoid or somehow bypass their payment policy, they will block it. So how do we really integrate Apple and Google payments into the application? And the solution to the mobile framework was to use the capacitor library because capacitor allows us to create cross-platform application. Because it's a native runtime of the web application inside a native app. And it means that you can write the code only once in JavaScript, in this case in Angular, and build it for iOS and Android automatically. And by the way, all of these technologies can be applied to any front-end framework, Vue, React, not only Angular, but I will explain it in the Angular specifics. So when we integrated capacitor, there was absolutely no need for Ionic components and no need for Ionic dependency because capacitor is basically just a web view wrapper within a native application, and it provides you a bridge to the device API. Means you can talk to the device API, you can trigger features like camera, file system, notifications, geolocation, and many, many more. And as I mentioned, our application relied heavily on the browser API, and in many applications on the IT market, you would see like applications like this, which have mobile platform, web platform, you will see code like this. If we are in a mobile app, do one thing, or if we are in a web application, do another thing. And all this if-else story spreads all over the app and makes the code unmaintainable and unreadable. And this is what we want to avoid by any means. So initially we had one application in the Enix monorepo and around 70 feature libraries which we used. So we added a second application, mobile app, to the Enix applications. And the solution to avoid this logic was so previously, for example, we used window open for opening new tabs, but this is not possible on mobile because there are no tabs on mobile, right? So how do we solve it correctly? The solution is to abstract this away behind an interface, so hide this functionality. And we could create an interface link opener with an open method, and it needs two separate implementations for mobile and for web. So link opener web service would just trigger the previously shown window open to open a new tab, and link opener mobile service should trigger the browser plugin of capacitor to open the in-app browser. So these are two separate implementations. And the question is, how do we call the correct one at runtime? And this is possible with one feature which, in my opinion, makes Angular stand out from all other UI frameworks. This is our injection tokens. So with injection token, you can say, for this application, I want to provide this service, and for another application, another service. And if only one service is used in the app, the tree shaker of Angular will not include the another one which is not needed into the bundle. So you can literally tell at build time what service you want to use, but it's also possible at runtime if you use both, for example. And this way, our features all only depend on the abstraction. So this is a classical application of dependency inversion principle. Just depend on the interface in your feature. And this is how we manage to not change the existing code and existing logic of features. The next point, which is important, is you have to enhance mobile user experience, because every time you submit your application with some fix, or this is just an initial submit, the real testers will download it. So real human will download it, your app from internal testing of App Store and Google Play, and they will test it manually. And if the app doesn't look good, they won't let it through the review process. You will get feedback and you will have to fix it. So the app has to be adapted for the mobile device. The design, buttons, accessibility, everything has to be usable and readable on mobile devices. Second of all, you for sure know there are these back and forth buttons in browser to navigate the browser history, but none of this exists on mobile, right? So you have to implement the gesture support to be able to swipe through the browser history. For example, like in Instagram, you swipe through the pages. And also to make your application different to the web app, because you don't want to ship the same, right? You can enable push notifications and engage with your users with relevant notifications, or for example, you can lead them to your payment process. But assuming you have started developing such an app, how do you deploy this application? So for this, you need two developer accounts at Apple and Google. You need to log in into the developer console of Apple and Google, and you have to define your application bundle ID and package name. This is the same story, just different namings. So this is an ID which stays with your application for a lifetime. And your app can have description, name, title, logo, pictures, and all of these can change through the lifetime of application. You can change it if you want every day, but bundle ID always stays the same. And the deployment tool is Xcode and Android Studio. So you upload your application to the App Store and Google Play. And in my experience, it takes around 2-3 days for a review so that testers download your application, test it, and approve it or provide you feedback to fix. And what is actually about the in-app payments, right? So this is why we even create such applications, to collect money, right? So you need a payment provider because from your front-end code and your back-end code, you want to speak to a single API because payments on the iPhone and on an Android are two different things and have different implementations. And also, payment provider will handle all sort of events that can happen during this process. Purchases, refunds, errors, timeouts. Payment provider does this all for you. And you will also find very useful, informative dashboards within your payment provider. So all the statistics about purchases from both stores in one place. And for example, you can see there an information, how long does it take a user since he or she landed on your app to purchase the first product. So you can optimize your app with it also. Very useful information. And so this technology stack for Angular and Capacitor, there are two main players as payment providers on the market, Conversion and RevenueCat. None of them are completely free. They are free to a certain degree, to some certain point of revenue. And above that, for example, RevenueCat is a bit more expensive. You have to pay 1% of your revenue as a fee to RevenueCat. But RevenueCat provides better documentation and it has bigger clients, so it's seemed a safer option. So we went with RevenueCat. And as next step, you need to decide what products you're gonna really sell in your application, and you have to create this product separately on the App Store and Google Play. And once they are created, you have to import them to the payment provider. And there you give them names, descriptions, and so on. But how do you access these products in your application? This is it's more simple as it seems to be. So you install the npm library of your payment provider, and in order to show your products, you have to call the get method of your payment provider to get the list of products you have. And once you get the list, this is a regular JavaScript list, you can show it within, for example, such nice cards with pictures, descriptions, names, each product, and each product can have a button, buy, for example. And once the user presses this button, you have to call the purchase function of your payment provider with the ID of the product. And at this moment, what payment provider does is it opens the native pop-up. So for sure, you have ever bought an app on the App Store or Google Play, so you get this nice pop-up where you can type your password or pay with the Face ID. This is completely the same, identical. Once the user is already has paid, has completed the payment process, the payment provider has now to speak to your backend. And this is very important. So your backend has to provide two endpoints for this to work. One endpoint is to save the results of payment. For example, the endpoint will get the user ID, the product ID, price, currency, time, and many different informations about the purchase, so that you can save it in your database. And next time when user logs into your application, you can know, okay, this user has this product, and we can unlock certain features for them in the application. And the second endpoint, which is important, is the status endpoint. So while this whole purchase process is happening, it can take minutes or seconds, your front end has to regularly call your backend. It's named polling. So for example, every 10 seconds with regular intervals of 10 seconds, you can call your backend for a status. So while the purchase is happening, you are polling for the status. And once you get the status, it may be success, maybe error, or it may be timeout, you can show this to a user on the front end in such a nice pop-up or snack bar, like green or red message for the user, so that he or she knows that the purchase result. And up until this point, we have already invested month of work, but we still had zero guarantees that our application will make it through the Google and Apple review. Because you have to pass first the Apple guidelines, then the Google guidelines, then submit your application for review. And some of their rules are, they can be very strict, I would say. I would formulate it so. For example, if you only dare to avoid Google or Apple payment procedure so that they don't get the commission, you get instant ban. So you can't publish your app anymore. This is illegal. This is illegal in their rules. You're straight to jail for this. And if you try to publish your mobile app really one-to-one identical to your web application without any differences, they will see it and they don't want such applications on the App Store. They will provide you feedback or they will just not let it through. For example, you build a cross-platform application for Android and for Apple, and if you accidentally mention Android somewhere in your Apple application, some link to Google Play or Android Word, they will also provide you feedback to remove that because Apple doesn't want any mentions to Android to the competitor on the App Store. And if your application is an MVP and you are teasing some features with coming soon placeholders, Apple thinks it doesn't look like a ready app, ready for the users. They don't want it. And if your application is just another calculator but with payments, it doesn't provide any additional experience to the users because there are already thousands of calculators on the App Store and they will just reject it. They don't want it. And they also don't want any bad design, so you have to consider it. And we have studied these guidelines very carefully and we were pretty lucky to pass the review without any feedback on the first try. And for more than a year for now, we haven't had any feedback at all from Apple, besides the automatic tests. No rejections, no feedback at all. And once you have finished with that, you are ready to publish your application and generate revenue with it and make profits with it.
Hey, are you done?
Yes.
With the talk?
Yes. Now I'm ready to answer the question.
Sorry?
Now I'm ready to answer the question.
Oh, okay. Apologies. I then have a few questions. First one would be to know, do you have any common pitfalls when converting web apps to mobile apps?
Any common pitfalls?
Yes.
I think the most pitfall I saw in my experience is Safari browser because the web view in an iOS application is actually Safari. So if something doesn't work in Safari, it won't work in the Apple web view. So
Yeah.
you have to really test the application carefully in all
Okay.
browsers.
And do you have any tips as on how to share a code base between web and mobile?
That's the point, that web and mobile actually use the same code base, literally completely identical. Besides of these, where we use the dependency inversion, where we could call different services different implementations of the same thing. For example, like opening in browser pages in a new tab,
Yeah.
or opening an in-app browser in a mobile application.
Yeah, but it's more like for APIs that might be specific that you don't have on the web or the opposite.
Exactly. So all the specific stuff you handle with this dependency inversion. But beside of that, the whole code base is identical because this is really cost-efficient solution. We could also write the app from scratch. It would take years because the web app already had hundreds of thousands of users. And imagine writing such application from scratch. It would take a lot of time. So this is like cost-efficient solution using the same features, same code base.
Yeah, that way you don't rewrite it. So that's always nice. Maybe at the final, do you have any tips to handle the review processes and requirements?
Yes, actually, Apple and Google have their guidelines published online. These are
Okay.
nice PDFs, and you should read through them and really check if your app complies with every single point. Because they will download your app, test it manually, of course, but they also see what features you use on the app metadata. So they see if you access camera, if you access contacts, or any
Yeah.
device information.
If you ask for
So
too much privileges, pretty much. Yeah.
yeah. So there is
Okay.
no way you can avoid complying with the guidelines. So Apple and Google is the boss here. So they decide.
Indeed. Okay, perfect. Thanks again for your amazing talk, Daniel. And people can reach you out on LinkedIn, Twitter, and a few other places, I think. Do you have any
Yes,
other social that you prefer?
absolutely. So my last slide was a QR code to my LinkedIn, which you can scan and
Yeah,
ask me questions there about this particular topic. Also subscribe because I regularly post my insights about front-end development, software development in general, and Angular, of course.
perfect. Also, yeah, LinkedIn is a stable platform, not going anywhere, so that's good.
Yeah,
All right. Thanks a lot.
thank you very much.